Moving on with Unit 5. So Unit 5 is all about linear functions, and in our last learning target, we learned how to compute the slope, either given 2 points or from a graph. In this video, we're going to start talking about learning target 5b, which is all about equations of lines. And in this video, we will learn how to, given a line in slope-intercept form, we can find the slope and the y-intercept, or the other way around, if I'm given the slope and the y-intercept, I could write the line in slope-intercept form. I'm sorry, I do have one typo here. That should be an L for slope. The second thing we'll be able to do is given an equation of a line in slope-intercept form, that we'll be able to then graph that line. So let's start with our first definition. So a linear equation is an equation that models a linear function. So we've seen what linear functions and linear graphs look like. There are straight lined graphs. And a linear equation is what represents that graph. In a linear equation, the variables cannot be raised to a power other than 1. So some examples of linear equations would be y equals 2x is an example of a linear equation. Another one could be y equals negative 5x plus 7. Would also be a linear equation. So both of these are linear equations. And in math, it's important to make sure we understand not only what examples are, but what are non-examples. So what are some examples that are not linear equations? One of them would be y equals x squared. This is not a linear equation. This is what we call a quadratic equation instead, and we'll talk about that in a unit later on. Another example of something that is not linear would be y equals 2 to the x. That's what we call an exponential equation, which we'll also talk about later on. Another one could be y equals the absolute value of x. This is not a linear equation. This would be an absolute value equation. So it's important to not only understand what are linear equations, but what are some things that are not. And in later courses and in later units, we will be talking about these. So all three of these are what we call non-examples because they are not linear equations. The next definition we need before we get our first equation is a linear function may cross the y-axis at any point, and a y-intercept of a graph is the coordinate pair where the graph crosses the y-axis. Now I want to highlight the word coordinate pair here. So a y-intercept needs to be written as a coordinate pair. And remember, our coordinate pair would be our x comma our y. But since a y-intercept is where we cross the y-axis, our x value will always be 0 then. So we're looking for 0 comma a number is our answer to a y-intercept. And anytime we're asked for an intercept, we'll talk about x-intercepts later on in this unit as well, but for now, anytime we're asked for an intercept, and in this case a y-intercept, we must make sure that we're writing our answer for that as a coordinate pair. So a y-intercept is written as 0 comma the y value. Let's look at our first type of linear equation. So slope-intercept form is one of the 3 main forms that lines come in. So this video is going to focus all about slope-intercept form. And what slope-intercept form says, so the slope-intercept form of a non-vertical line is y equals mx plus b. Where remember m is our slope, we talked about that in our last video, and 0 comma b is our y-intercept. Notice it is written as a coordinate pair, so we didn't just say that b is our y-intercept, but that 0 comma b is our y-intercept. For this first set of examples, what we're going to do is I've given you guys the slope-intercept equation, and we're going to find and identify the slope and the y-intercept. So we're not solving anything, we're not plugging anything in for x, we're just trying to get the information from the equation and translate that into what it means. So we're going to find the slope and y-intercept for each of the following linear equations. Let's look at example 1. It says y equals 5x minus 2. So if I'm looking at our slope-intercept form, we're dealing with y equals mx plus b. So our m is the number that's being multiplied to the x. So in this case, our 5 is the m, and our b is the number that's being added to that. So our b here would be -2. I can use that information to then list my slope and the y-intercept. So our slope is our m value. So in this example, our slope would be 5. And our y-intercept is 0, b. So this will be 0, -2. Let's look at our second example. We have the equation y equals -7x plus 3. Let's identify our m and our b values. Our m value is -7, since that's the number that's being multiplied to the x, and our b value is +3, since that's the number that's being added. From here, we can now find our slope and our y-intercept. So our slope is always our m value, so our slope is -7, and our y-intercept is 0, the b value, so 0, 3. Again, I just want to keep re-emphasizing how important it is to write your y-intercept as a coordinate pair. Why don't you guys pause the video and try example 3 on your own first, and then we'll check it together. Example 3 says y equals -1/2 x minus 3/2. I'm going to first identify what the m and the b values are. So our m is -1/2, and our b value is equal to -3/2. Remember, we want to take that negative sign with it. That can then help me find my slope and our y-intercept. So our slope is going to be -1/2, since it's the m value, and our y-intercept will be 0, -3/2, since that's the b value. Okay, example 4 says y equals 4x plus 6. Why don't you guys pause the video and find the slope and the y-intercept on example 4 first. Okay, to check example 4, we're going to need our m value, which is 4, and our b value is +6. That can then tell me that my slope is equal to 4, and my y-intercept is equal to 0, 6. So in these first 4 examples, we practice, if we're given the equation, how can I identify the slope and the y-intercept from there? And we really talked about making sure to write your y-intercept as a coordinate pair. All right, let's look at examples 5 through 8. So examples 5 through 8 say write the equation for the line in slope-intercept form given the slope and the y-intercept. So we're doing the opposite now. So in all of these, we're given the slope and the y-intercept, and our job is to write the equation in slope-intercept form. So remember, slope-intercept form, we have to know what that means. That's that y equals mx plus b equation. So to be able to write this in slope-intercept form, I'll need to know what the m value is and what the b value is. Our slope, remember, is always our m value. So in example 5, our slope is -4/5, so our m value will be -4/5. And then our y-intercept is always 0, b, so this tells me that b will then be +7. From here, I can substitute those into y equals mx plus b form. So my final answer would give me y equals -4/5 times x plus 7. And that will be our final answer for question 5. So as we can see in this one's, we're just going backwards of what we did with 1 through 4. Why don't you guys pause the video and do example 6 on your own first, and then we'll check it together. Let's check example 6. They gave us our slope is equal to 3/2, so that tells me my m value is 3/2, and your y-intercept is 0, -1. So that means our b value then is going to be -1. When we sub this into y equals mx plus b, which is our slope-intercept form, and they ask for slope-intercept form, we'll get y equals 3/2 times x minus 1. Technically, we get plus and -1, but I'm going to go ahead and write all of those as just minus, and in this case, the 1. And that will be our slope-intercept form. Okay, why don't you guys pause the video and do example 7 on your own first as well. Okay, let's check example 7. So they told us our slope is equal to 5. So our m value is 5, and our y-intercept is 0, 2. So that means that that b value then is going to be positive 2. From here, I can sub directly into slope-intercept form, which is y equals mx plus b, and I'll end up getting y equals 5x plus 2. And there is our slope-intercept form. Oops, we kind of wrote over the next problem. So there is our slope-intercept form. Okay, example 8. Why don't you guys pause the video again and try this one on your own first. Let's check example 8. So we have slope equals -7. So our m value is going to be -7. And our y-intercept is 0, -5/8, which means our b value, yes, a fraction, and that's okay. It will be -5/8. Using our slope-intercept form, which is y equals mx plus b, we'll get y equals -7x minus 5/8. And that was a 5. And that's our slope-intercept form and our final answer. So again, in problems 1 through 4, we were given the equation, find the information, so find the slope and the y-intercept. We wanted to make sure in examples 1 through 4 that we wrote our y-intercepts as coordinate pairs. And then examples 5 through 8, we flipped that and we were given the information and we were asked to find the equation in slope-intercept form. Now you'll notice that when it said it, the instructions just said write it in slope-intercept form. They didn't tell us what that equation was. We needed to know that slope-intercept form is y equals mx plus b. So this video is going to address all about slope-intercept form, and then we'll look in other videos about two other forms that we have. We want to make sure we have the name down to the equation. So slope-intercept form is the y equals mx plus b equation, where m is our slope and 0, b is our y-intercept. From here, we're going to start graphing some of these. So example 9 through 13 say graph the following functions. In example 9, we have the equation y equals 2x minus 1. So this is in slope-intercept form, since it's y equals mx plus b. And we can go ahead and pull the information out of the slope and the y-intercept, and then we can graph this. So we're going to do kind of 2 steps in here. We're going to do what we did in examples 1 through 4 and first find the slope and the y-intercept, and then use that information and talk about how we can graph it. But I first want to make sure I'm finding this information before I go try to do stuff on the graph. So why don't you guys pause the video and tell me and find out what your slope and your y-intercept is in example 9 first. Let's check our slope and our y-intercept. So in example 9, our slope is equal to 2, since that's the number being multiplied to x, so that's our m value, and our y-intercept would be 0, -1, since our b value here is -1. But our y-intercept, we know, we write those as coordinate pairs. Let's now use this information to graph. So to graph a line, I would need 2 points. Well, I have 1 point, so let's go ahead and plot our y-intercept. So I'm at 0, -1. So there's 1 point. I need 1 more point to be able to graph a straight line. That's where the slope is going to come into play. So in our first video in this unit, we learned about slope and how we could find that on the graph. And remember, our slope is equal to our rise over our run, and we can kind of use that to calculate how I move on this graph. Well, my slope right now is just an integer, so I'm going to rewrite this as 2 over 1 so that I have a fraction to work with, where the 2 is going to be our rise and the 1 is going to be how far we're running. So what the rise tells me is how far I go up or down. Now, because 2 is a positive number, that means I'm going to go up 2. So from the y-intercept, I'm going up 1, 2. And then the run tells me how far I move to the right. So that means I move 1 to the right, and then I plot my point. So from here, if I pull another color, what we did was we went up 2, 1, 2 for our rise, and then we went to the right 1, and that was our run. So our rise over our run gave us our next point. And we started from our y-intercept, since the slope is from points that are on the graph. From here, what we can do next is we can actually draw in our straight line by connecting those 2 points. So you would want to make sure you're probably using a ruler or a straight edge. I'm going to insert a line into here and graph it through these 2 points then, and that will be our straight line for us. Let's look at example 10. So example 10 says y equals 3 over 2 times x plus 3. And they want us to graph this equation. Well, to graph a line, I need to know what my slope and my y-intercept are. Why don't you guys pause the video and find your slope and your y-intercept first. Okay, our slope is equal to 3 over 2, since it's the number that's being multiplied to the x, that's our m value. And our y-intercept is going to be 0, 3, since that is our b value. Again, make sure you're writing your y-intercept as a coordinate pair. Okay, to use this information, to graph a line, remember I need 2 points. Well, I have 1 point, so let's go ahead and graph our y-intercept, which would be at 0, 3. Now to find the second point, that's where the slope's going to come into play again. So remember, our slope is equal to our rise over our run. So from here, I want to rise 3, and since 3 is positive, it means I'm going up, so I'm going to go up 1, 2, 3. Then from here, I'm going to run to the right 1, 2, and that will be where my next point goes. So starting from the y-intercept, we can use the slope to rise by 1, 2, 3, and then run by 1, 2 for this example. That is enough to give me a graph of a straight line. So I can go ahead, use my straight edge, and I can insert my straight line into this. And I want to make sure on my graph that I'm extending my straight line all the way. So there we go. So we have the whole graph, and we want to make sure we're filling up the entire graph. So make sure your lines are going through the whole thing. The other thing I want to point out about this rise and this run is when I have a positive number over a positive number, we tend to go up and then to the right because that would be positive and positive. But equivalently, this could be -3 over -2, since a negative divided by a negative would give us a positive. In this case, I'd go down. Let me actually write that. I'm going to write that in a separate color so we can see it. So I could equivalently do -3 over -2, since that is equal to +3 over 2. And in this case, I would go down 3, so I'd go 1, 2, 3, and then to the left, 1, 2. And I'm going down because the 3 is negative, and I'm going to the left because the 2 is also negative. So since they both have a negative sign, that's why I'm going down and to the left. And you'll notice that gave me another point that was on this line. Now, sometimes this can be helpful when we don't have enough space on our graph to go up and to the right. Sometimes we need to go down and to the left instead. Just make sure, though, that you're doing the opposite on both. So the opposite of up is going the down, and the opposite of right is going left. And so I need both of those to be negative so that when I reduce that down, I would still end up with +3 over 2. Okay. Let's look at our next example. So in example 11, it says y equals -1 over 4x plus 2. Well, to be able to graph this, I'm going to need to know what our slope and our y-intercept are. Why don't you guys pause the video and find your slope and your y-intercept. Okay, our slope is going to be -1/4, since it's the number that's being multiplied to x, so that's our m value. And our y-intercept is going to be 0, 2, because it's 0, that b value. Again, to graph these, I'm going to start with our y-intercept. So I'm going to graph 0, 2 will put us right there. From here, our rise over our run is now a negative number. So in our prior 2 examples, our slopes were positive in both of these. And so because our slopes were positive, it made sense that I have a positive line lines aren't positive, that I have a line that is rising from left to right. So the positive slope told me that my line has to go up. So in both of these, I ended up having a positive slope, which is why the lines are rising. Well, in example 11, our slope is negative, which means our line should be falling. So this will be a good way for us to check our work as we keep going. So when we look at our rise over our run now, we have to make a decision. So we have one negative sign now. There's not a negative on both the top and the bottom. There's one negative sign overall. I'm going to stick that negative sign with the 1. So I'm making that choice. And the reason I did that is because I can now say that this is going to be down 1 and then to the right 4. So I'm still going to the positive direction on our run because 4 is positive, but I'm going down because our 1 is now negative. So from this point, I'm going to go down 1 and then to the right 1, 2, 3, 4, and that will give me our second point on this line, which we know is enough information to be able to now graph and connect these dots. So using your straight edge, I want to make sure I extend this line all the way through my graph. And there we have our straight line. So it makes sense that the slope is going down, that the line is falling, since I have a negative slope to begin with. And when we have these negative slopes, we have to make the choice where we want to stick the negative number. I always put it in the numerator, and that just reminds me that I go down instead of up, and then I'll always go to the right. All right, let's look at example 12. Why don't you guys pause the video and try example 12 on your own first, and then we'll check it together. Okay, we need to start with what our slope and our y-intercept are. So our slope is going to be equal to -3 because it's the number being multiplied to x, and our y-intercept is going to be 0, +5. I'm going to start by plotting 0, +5. So we're at 1, 2, 3, 4, 5. Now from here, I need to figure out how to find my second point, and that's going to rely on my slope. So -3, I'm going to rewrite as -3 over 1, since I want to know what my rise or my fall is over my run. That's telling me that I'm going to go down 3, since the 3 is negative, and I'm going to go to the right 1, which will end up giving me a graph that is falling, which makes sense because I have to have a negative slope since my slope was negative. So we'll go down 3, so 1, 2, 3, and then to the right 1, and I'll put my second point right there. From here, we can connect those together since 2 points will form a straight line. Whoops. So using a straight edge, that can either be a ruler or maybe an ID, or I think a Post-its would also work, but using a straight edge, I can connect those two. Again, making sure your graphs are going the entire span of the graph, which might seem silly right now, but in our next unit, I know what we're going to be doing, and it's going to be helpful to have those graphs that draw the entire portion of our graph paper there. Okay, let's check example 13. So why don't you guys pause the video and do example 13 on your own first, and then we'll check this example together. Okay, in example 13, for all of these I'm graphing, so I need to know, well, what is my slope and what is my y-intercept? So our slope this time is going to be equal to -1, since there's that invisible -1 in front of the x, so that's our m value, and our y-intercept is at 0, 3. So we'll plot our y-intercept first. Now from here, I need to use my slope to help me find the next point. I can rewrite -1 as -1 over 1, and that will tell me that I'm going down 1 and to the right 1. So when I do this, I go down 1 and then I move to the right 1. Well, that didn't take too long, and I found that second point right there. Yes, these guys are closer together than others, but that's just because the slope is not as steep. But I am going to end up with a negative slope since the line will be going down when I connect those. But that's perfect because our slope was negative to begin with over here, so it makes sense that our line is falling. Using my straight edge, if I connect these together, I want to make sure I'm graphing, there we go, over the entire coordinate plane and extend it up this way as well. There we go. And there is our graph for example 13. This is the end of the first part of learning target 3B, or I'm sorry, learning target 5B, and in this video it was all about slope-intercept form. So in our next video, we're going to talk about another type of equation. So right now you want to make sure that you've got slope-intercept form down. And in slope-intercept form, that is the y equals mx plus b, where we know that our m is our slope and our y-intercept is going to be 0, comma b. So hence the name slope-intercept, because we get our slope and our y-intercept from there. And that's going to actually be helpful to connect both the name and what it's telling you and the equation, because in our next one, we'll have two different pieces of information. So slope-intercept gives us the slope and the y-intercept, and it's the equation y equals mx plus b.